Welcome, everyone. My name is Igor Dvoretsky. I am a developer advocate for Cloud Native Computing Foundation.
And I'm Rob Hirschfeld, CEO and co-founder of RHEL.
And today we'll speak with you about how to build Kubernetes clusters, highly customizable Kubernetes clusters with the tool called Kubespray, previously called ex-Kargo. And so first of all, why should you use Kubernetes and what are the reasons for using Kubernetes for deploying, for running that on your clusters, for using it for running your applications and so on. First of all, Kubernetes is one of the largest projects in the world, one of the largest open source projects in the world. With its scale and community velocity, it can be even compared to the Linux kernel because of their really big community, big code base, and really fast growing and fast process of development. Speaking about the technical aspects, Kubernetes supports multiple runtime engines. That means that you may, using container runtime interface, you may easily swap different runtime interfaces and runtimes to use different configurations for running your containerized workloads. It supports multiple networking solutions. So if you have any preferences in how to run and deploy networks for your Kubernetes cluster, you are able to choose. Kubernetes can be run in almost every environment. So you can run Kubernetes on premises, on bare metal, on OpenStack, of course, on almost every public cloud provider. Almost every public cloud provider today provides the native support of Kubernetes. And Kubernetes is open source. It's written on Go. It's easy enough to understand what's hidden in the code base of Kubernetes and how to extend and contribute there. So speaking about the state of ecosystem of Kubernetes ecosystem and ecosystem of installs for Kubernetes. First of all, we have more than 30 community-driven and commercial distributions and options how to deploy Kubernetes. The most popular community-driven options that are kubeadm, probably one of the most popular one, and it's not the default one, but many getting started guides for Kubernetes recommend kubeadm as the first way how can you install and play with Kubernetes and use it for your production environment as well. It's also kops, again, the native Kubernetes and community-driven tool. It was primarily developed for running Kubernetes on AWS, but it also allows you to deploy Kubernetes on the different platforms. And Kubespray. We'll speak with you about Kubespray today, and I'll provide you some more details about what the project is, what are the goals, and what is under the hood. So a few more Kubespray alternatives. How can you deploy Kubernetes in a different way with different tools? That's tool named Kraken by Samsung. It's Bosch Kubo by Cloud Foundry, Mesosphere Kubernetes, Ubuntu Charms, Rancher, and lots multiple different options, including Docker, for example, that it's not available yet, but a few weeks ago, Docker has presented it in Copenhagen, the ability to run Kubernetes in a native way, in the same way as you can run Swarm today with Docker. So a few highlights about Kubespray and exactly why should you use Kubespray and what are the benefits you may have with using Kubespray for your Kubernetes development, Kubernetes deployments. So Kubespray, again, it's a community-driven project. It was started by the group of independent developers. The original name of the project was Kargo. Today it's Kubespray, but anyway, if you're looking for some documentation in the internet, you may find also some guides also for Kargo. Kubespray is based on Ansible. It's one of the biggest benefits of Kubespray as a set of tools, because if you know Ansible, you know Kubespray. It's easy to customize the default Kubespray options. It's easy to extend it with some extra configuration if you require some, but it's not available in the default shipment and so on. Kubespray also provides deployment and lifecycle management for Kubernetes. There's multiple tools. There are multiple tools that allow you to install Kubernetes, but they don't allow you to manage it easily. Kubespray will do all the job for your Kubernetes cluster. Kubespray brings you the huge number of the configuration options. So again, Kubernetes can be, any typical Kubernetes cluster can be installed and configured in the multiple ways, and Kubespray will allow you to do that. Again, it's Ansible-based, so if there are no default configuration options available, like on a default shipment, so you can easily extend it with your, if you have some Ansible knowledge. Kubespray today is the incubated project for Kubernetes. It has it's joined Kubernetes incubator approximately 1 year ago, and I hope that it will be credited to the official Kubernetes project really soon. And on this web page, you may find all the information about the project. So it's on the Kubernetes incubator, organization on GitHub, Kubespray. So everything is there. And the key features of Kubespray.
Just a couple. Just a couple of features.
Yeah, the major features. So first of all, Kubespray allows you to have automatic HA. Rob will run a brief demo of that. How can you use it with this feature? Kubespray allows you to rotate certificates. Kubespray can be easily integrated into multiple cloud providers, including OpenStack. And OpenStack was one of their first integrations for the cloud providers. Kubespray is secured by default. It can run upgrades of your Kubernetes clusters. And again, we'll have a few demo minutes for that. Incremental node add. It can spin up some different projects like Helm. And also it allows you to, it brings you in the multi-platform CI/CD. This diagram describes all the variety of configuration features and all the variety of configuration options that you may have with Kubespray. So you can run Kubernetes with Kubespray on Google Cloud Platform, on Amazon, on OpenStack, on Azure. DigitalOcean integration is coming. Speaking about the on-premises options, it's the pure bare metal. It's VMware, KVM-based deployments, Vagrant, and so on and so on. So again, that's all these configuration options are limited only by your knowledge of Ansible, so you can easily extend how your Kubernetes cluster will look like, where it will run, and so on. Again, multiple operating systems are supported, including Ubuntu Debian family, including Red Hat family, CentOS, RHEL, Fedora, Atomic, and so on, and CoreOS Container Linux. A few networking options for layer 2, that's WIF and Flannel SDNs. For layer 3, it's Calico Canal, and Roman and OpenContrail integration are also coming. You may use multiple container runtimes with Kubespray. It's Docker and Rocket. Today, Rocket is supported only for control plane, but again, if you see some benefits of using Rocket for your control plane, you can use Kubespray with these options. And multiple deployment modes. So now it's demo time. So, Rob?
All right. Let's see.
Yep.
Thanks. All right, so I'm going to spend a little bit of time setting up the demo before I jump into it, because this is potentially one of the most boring demos you'll ever see, because it's an Ansible install. And it's about a 30-minute Ansible install, so I'm not going to run the full install for you. So first, how many people here have used Ansible? Yay, good. OK. So we're going to have a little bit of taking on faith that Ansible works from this, but I will actually kick off a demo, and we'll show you where things go. And there's I apologize, we're not doing this on OpenStack. When we submitted this talk, I was doing OpenStack deployments using Ansible with a wrapper. Today, we're actually going to do bare metal Kubernetes installs. So if you're looking at doing Kubernetes underlay work, we'll show that. And I have a little bit of scaffolding around setting those up and doing the inventories. and building those dynamically. So you'll see that as part of building this session up. But the goal here is to show you a couple of base scenarios in which we're using Kubespray to build Ansible, Kubespray to build Kubernetes, which is all Ansible work. So any questions before we start about that? Has anybody tried Kubespray before we're doing this? We got a couple of people. Great. And so one of the things I did was I pulled in the very, very latest Kubespray. And so one of the things that's changed, if you haven't tried Kubespray in a long time, is that they changed the auth pattern. And so basic auth is off by default. So I'm going to be working on the servers directly and not trying to hit all of the pieces. Not trying to create a whole bunch of Kubernetes capabilities. One of the things that I would tell you is that if you're just trying to get Kubernetes installed, right, then kubadmin is actually a really nice way to build a small cluster. If you're doing it on Amazon, Kops has a lot of hardwired content. The point here is not that we're trying to create a one way to install Kubernetes. And actually a lot of the tools, including Kubespray, are converging to using kubeadm as the underlying piece to drive installs. And we'll talk about that. And one more thing before I start the demo. We have some bonus content at the end of the demo talking about a advanced Kubernetes install pattern called node admission. So hang on for that, and we'll take, and interrupt if you have questions, just jump in for questions. So I have a whole bunch of servers staged up at a company called Packet. Those servers are expressed in the scaffolding tool. What we use is something called Digital Rebar that does physical infrastructure underlay, and that allows us to build different Ansible inventories dynamically. So if I have 3 different inventory profiles that are set up. The one I used to do a install first. I have two set up. I need to modify one more. We have a basic cluster on some faster machines. And then we have an existing cluster on another set of machines. So within this machine, we have about 20 servers, and I have 2 different inventory sets that are played for that. When you build a Kubespray inventory, this is one of those 2. And so what I would do is, just like you'd do in any time, you'd create a inventory. Sorry. I'll throw it through JQ so it's a little bit prettier. Obviously, everybody here is used to Ansible, so the first thing that you need to do in building any type of Ansible deployment is to understand the groups that you have to build and the host information that you have to build. Kubespray is pretty straightforward from that perspective. There's an etcd. Hold on, I'll show you on here. There's an etcd cluster that you need to define. So Kubespray will set up the etcd cluster for you. There's a set of kube master nodes that you need to define. In this case, this cluster has 3 nodes in that host group, and so that will automatically build an HA cluster. It will not install with an even number of nodes, so it will actually fail if you try and give it the wrong information there. There's some of the things about what Kubespray's done. It's literally been in development since the 1.1 days. There was originally some Ansible code that wasn't being maintained in as much a community way, and this forked off of that as Kubespray in the 1.1 era. Kubernetes 1.1, it progressed, it changed to Cargo, and then it changed back to Kubespray. They had a neutron nebula type of, if you all remember the early networking days for OpenStack. They had a copyright conflict issue. And so with that, from that perspective, I have an inventory file with my hosts identified in it. Before I want to start any large, so Kubespray is going to be, especially over this, since I'm actually using a data center in New Jersey, there's a little bit of delay. It would be about a 30, 40-minute run to make all this stuff work. But before I go, I actually want to test that this system is running. So I'm going to take this inventory file, I'm going to pass it through, and I'm just going to ping the infrastructure. Can everybody read I got the font big enough? Yay. So I'm going to go ahead and ping all the servers and make all that work. So at this point, if you're not used to Ansible, right? Now I can actually talk to the servers. I've confirmed I have identity and SSH access and things like that. And then from that point forward, what I would do is I would do a very simple playbook install. So the simplest one that you can do is to literally just run the Ansible playbook, pass in your inventory, and give it the cluster specification. Okay. If I do this, it will go ahead and start running my install. What I can do to make this a little bit more interesting, if you'll bear with me for a moment, I can grab a profile. Oh, I thought I didn't create it. So I'm going to create a new Kubernetes deployment profile. I'll just call it demo. Okay. And then I'm going to grab some machines that aren't assigned in that demo, in that profile. Just so you can see me kick off an actual install. So in demo, what I'll do is I'm going to grab cluster, a couple of machines for my cluster. So there we go. And let's see, there's 14. So what I've done here is I've just built a basic cluster out of a couple of machines. If I jump back over to here, I can pass in that demo. So I can use that profile to spin up my cluster instead. And then this will validate that I actually have access to those machines. This is all pretty straightforward Ansible stuff. And then if I do that, I can come back. Sorry. So by passing in the variable, what that's going to do is it's going to pull a different block of machines. My environmental variables would pull one of my other clusters. So this is just going to start running Kubespray as an installer. And you get the classic Ansible scrawl through the system. Pretty straightforward so far. Everybody with me? Cool. This is not, I told you, very simple. If you're used to Ansible, this is about as basic as it gets. The place where it starts getting really interesting is when I can take one of my existing clusters. So in this case, let's see, this isn't the one I want to upgrade. What I want to be able to do is I want to take, good. Okay, so this is, I'll expand this. So this is my other cluster, what I was calling the play cluster, or the fast cluster, has a little bit faster machines. And you'll notice that I have CoreOS 1.81 when I set this one up. So I've been setting up clusters all day. And the obvious thing here is this is not the current version. I know all of you immediately said, wow, that Rob's running a really old version of Kubernetes. It's almost 1 dot version out. And so the idea with this is that what I would want to be able to do is take that cluster and have an automated upgrade for it. You have two choices with this. If you're impatient, what you can do is you can go ahead and just tell it that you're going to switch the version to 1.8.2, and it will go through. Behind the scenes, Kubespray is actually using a whole bunch of containers. So the popular way, this is going to be a shocker, popular way to install Kubernetes is in containers. So Kubespray, like most of the other deployment tools, actually brings in all of the components of Kubernetes in containers. And so what this command would do is it would rerun the Kubespray playbooks. They're idempotent mostly. And the cases where they're not are things like certificate regeneration. Those get tricky. And so this would literally go through, switch the container version, and pull down new containers and roll that out through the infrastructure. There would be downtime. Because, well, for this one, there probably isn't because it's a dot change. But if you were making a bigger step change, you would have some times where the versions weren't in sync. But never fear. Kubespray has a way to do the upgrade. So they have a separate cluster definition that will actually synchronize your upgrade through a sequential process. So the community has gone through and said, if I want to do an upgrade, then I need to step through etcd, there's actually about 10 different steps that they go through. They're pretty well documented. And so instead of just asking for my cluster definition, what I can do instead is say upgrade cluster. And then specify my 1.8. I don't need my password set there. And then if I go through here and let it run, and I have no idea how long this is going to take, it will go through and actually run this process against my cluster, and then when it's done, sometime, probably before we run out of time, but it'll actually go through and do that process. It goes without saying, practice this before you go to production. I always say that, and everybody should know it, but it always bears repeating. One of the nice things to know about Kubespray is it has a really active CI infrastructure, and so the CI system actually tests a lot of these different scenarios. So because it has so many knobs that you can turn, and I'm going to show you the configuration in a second, because it has so many knobs you can turn, it's really important that the CI system actually tests a lot of those combinations for you. But your mileage may vary depending on what you do. This is Ansible, so there's a lot of scissors involved with how it works. But it's going through. I'm going to leave it running in the background for a second. And I will show you. Cool. Everybody with me? Any quick questions? Awesome. Yeah, this is a demo with a lot of terminal screens, so sorry. If you are looking at the Kubernetes configuration, most of the configuration in the Kubespray Ansible playbook is contained in this K8s cluster YAML file. And so if you are choosing to make different changes like different directories, different versions, changing your password. So in this case, I'm overwriting some of their logic to change it from token auth to basic auth and to use OIC, or not to use OpenID Connect. So even just glancing at this cluster file, you can see very quickly there are an amazing number of different options that have been turned on. The community is really vibrant here. And most of the people who are doing real Kubernetes installs on premises that I've talked to are using Kubespray. Vendors are switching to use it. There is a high degree of safety in using this as your Kubernetes install strategy. Especially if you're looking at a bigger scale. The downside is that it's a little bit slow. Ansible is not the fastest way to get nodes up, and so we'll talk about some of those things in the bonus content, which we're cruising to, just in good time. And then it's also important to note, you can actually choose a lot of different networking topologies. So if you are in the market, if you're installing Kubernetes and you don't know what networking topology to choose, like Calico Weave, Romana, Open Contrail is coming out with plugins for this, just straight IPs or VLANs. Most of those are already supported here, and so you can build a cluster, test it and tune it, and have things go. One of the reasons why I'm showing you the multiple clusters out of the same infrastructure is that you can then go in and actually do this type of deployment, multiple ones side by side, just like I've been doing to prep for the demo.
And even if you use Kubespray on some of the cloud providers, there is also native support of networking for these cloud providers, like for Google Cloud, Amazon, and so on.
Right. So there's sections in here for OpenStack, for all the cloud providers. So you need load balancers and service, but it will actually integrate into those load balancer infrastructures. So this is pretty sophisticated Ansible. It's not as sophisticated as Cola. I've looked at Cola and this also. I actually think this is a little bit more linear than Cola because it doesn't try and do quite as much. But this is relatively complex Ansible compared. It's multiple playbooks. It's a lot of parts. It's a lot of pieces. But nothing made my hair catch on fire when I reviewed it. And my hair's pretty flammable. Even things like you can turn on Helm, you can turn on Istio, dashboard. Some of these things are on by default. Some of these I've been tweaking as I've been trying to get the demo going. But the nice thing here is that if you follow these playbooks you're going to get a good, high-quality Kubernetes deployment out of it at the end in a very reliable fashion. One thing I would tell you is make sure that you understand the auth system if you're going to pull down the latest, because it's going to use RBAC, the role-based authentication, and you're going to need token auth and things like that to get configured. So budget time for that in building these up. Okay, so that's one use case that I wanted to demo. The other use case I wanted to demo, oops, and this thing's still going, yay. The other use case I wanted to demo is actually taking an existing cluster. Let's see, which one am I upgrading? I think I'm upgrading fast. So I'm going to go back to my Kubespray demo, and if I want to grab some extra resources on it, which I could do just by adding some extra nodes. Do I have an 11? Here's 10. So what I just did is I added 2 more nodes into my cluster. And this is a really good strategy for you if you don't necessarily want to build a 100-node cluster immediately. Build a small cluster, test it. And then once you've done that, then you're going to want to be able to come back and say, I really would like to expand the scope of my cluster. And no surprise, Kubespray has a way to do that also. So for that, what we want to be able to do is, okay, I don't need any of this. And there is a scale, there it is, scale, YAML. So what I can do here, let me make sure I end up with the right profile. Kubespray. Let me see if I got the right one. Yes. So now what I can do is I can go ahead and instead of giving it the command for rerunning it, I'm actually just telling it to scale it, and scale is optimized to do node additions, and so it doesn't try to set up all of the other infrastructure components. So, right, a lot of the time, so you'll notice, I keep saying that it takes time to do this. You're building, why does it take so much time? It takes time because you're pulling down a lot of containers, right? So there are downloads that you have to do. And then you're building an etcd cluster, you're synchronizing all the components, you're making sure that things come up in time, you're distributing certificates. I'd love to see it a little bit faster. That's why I'd recommend kubeadmin if you're just trying to play, because it's going to give you a faster experience. But it's not going to give you the breadth of capabilities and options that you're going to get out of this playbook approach. Okay. And so in this case, because I added a couple nodes, I used the scale playbook instead of just the regular cluster building playbook. It's pretty straightforward. Okay. And I have no idea how much these things are going to collapse and bang on each other. So let me take a second and see if my cluster is done. I colored them so I would know which one is which, but I have no idea if it's, no, not yet. So we'll come back at the end of the session and see if I've actually been able to upgrade. It takes some time. One of the things that this doesn't do, and you could optimize probably, some of my older code would actually jump in the middle, and then you just get an end, just the upgrade part. But the goal here isn't necessarily to be fast; it's to be able to have complete breadth. And if you do not fork, all right, community, please do not fork these playbooks and then go off on your merry way. The community's been really good about taking things back into the system and using that. And so it's obviously with CI it's a lot more helpful, and they have coding practices and standards that they're trying to enforce. But bringing things into the community is going to help everybody stay together. I've been around in OpenStack for a long time, and we're seeing a whole bunch of new people show up with new installers in Kubernetes. It's not adding as much value to me, and what I like to see, and the reason why our Racken's Kubernetes strategy is we give you a dynamic inventory and then run Kubespray, because we're not adding value by creating more installers, right? We're adding value by making it very easy to use the community ones, and by working to, if we find improvements, to feed those back into the community installers. We really don't want to create vendor ecosystems of installers. I've been part of that story before. It doesn't have a good ending. So let's see. I think that covers all the demo points that I was going to have. One other note that I'll just, since we're talking about the scaffolding, one of the things that's really fun for me with this is that part of what I can do here, I'm actually doing all of these operating systems we did, and this word will come up in the bonus content. We did a mutable OS installs, meaning that I don't actually write anything to disk. I'm booting the nodes, running an in-memory operating system, and then installing Kubernetes against that in-memory operating system. Obviously not fully a production deployment, but for testing a whole bunch of Ansible back and forth and over again, I can reset this environment just by basically rebooting the nodes. And then they're going to come back up with fresh operating systems, and then I can go and install all over again. And so my reset time in this environment is in the order of about 2 minutes before I'm back and running a new one, which is almost as fast as you would get out of a virtual infrastructure where you just pulled more virtual machines out of the system. So it's comparable for that. All right.
Yep.
Do we have questions about any of this before we jump into another related but slightly different topic? Please.
I guess that hostess was bare metal, so you're writing everything into temp or something, and that's why when you reboot, your node just wipes?
Yeah, it creates a memory disk, in-memory disk. Mm-hmm. Yeah, you can attach the drives too if you wanted to, but yeah. Makes sense. Questions about Kubespray capabilities? We covered pretty much all the stuff.
Yeah.
And I didn't show you the docs. Kubespray has pretty good docs.
Yeah.
And so, what I'm showing you, it's not that hard to build your own inventory and start making overwrites and things like that if you want to make changes on that.
Yeah. Again, the basic knowledge of Ansible will be enough for getting started with Kubespray and some customizations based on Kubespray.
Right. And the requirements are pretty minimal as a whole.
Yep. Okay, so the next part.
Yeah. You want to set this up, or do you want me to?
Feel free to continue.
All right. So how many people have heard the term immutable infrastructure? Okay. So it's about a third of the room. So there's a very important concept surfacing, especially in the containerized world, called immutable infrastructure. Some people don't like this term. Basically, what it means is that when you set up servers or containers, you do it, or virtual machines or servers. What you're doing is you're not doing configuration on those servers really after they're running. So what you're doing is you're creating a system with all of its configuration, all of its units, all of its components. You deploy that. You do a minimal amount of configuration. All right. So think of it as instantiating an object. So you give it its initial configuration, and then the system runs. And if you have to make changes to that system, you destroy the system. Right? You never go back and say, "Oh, I need to patch this, my node or my Kubernetes from 1.81 to 1.82, like I was demonstrating." What you would actually do if you wanted to do that migration is you would destroy the nodes that were in the old version. You would bring up new nodes and install the new version on those nodes. Right? Containers, if you think about it, always operate this way. You create a container, you ship the container, you run the container. You never patch a container, you destroy it. Virtual machines in the cloud are very similar. A lot of people have been emerging to this pattern of saying, I have a machine, I set it up in my CI system so it has everything I need. I deploy that, I give it a little bit of configuration, and then it runs. And if I need to change my software or change its configuration, I destroy the machine and I bring in a new one with the new configuration. In a lot of cases, you keep the old ones running and then you gradually drain the old ones while you bring up new capacity. And there's a constant churn of infrastructure like that. If you want a good example of that, the Cloud Foundry Bosch pattern actually uses that as its primary deployment. So it's always deploying a new image and then tearing down the old images. And that has a lot of benefits for having very known, safe configurations, and it can be very fast to roll through new changes in a positive infrastructure. So the idea of taking Ansible and rerunning it on a node and trying to make your Ansible playbooks idempotent, the need for that goes way, way down because you're never reconfiguring a system. So people are very excited about that type of pattern. Everybody with me so far? That's immutability. It can be a crazy word until you sort of get your head around why we're doing it, but it's create, destroy, repeat instead of configure and patch. So there's a lot of interest in being able to deliver a Kubernetes node, and I'm sticking to nodes right now, not API or admin servers, but nodes. So I have a cluster, it's running, it's all happy. I want to scale it up, I want to scale it down. I want to be able to add a node and have that node come into the cluster. So I take an immutable image with Kubernetes in it, probably with Docker and kubelet. I provision that node. So I boot that node. To me, I'm saying boot, but cloud deploy is the same thing. So I take that node. It already has kubelet and it already has Docker. I tell that system, the only thing I have to tell it is, here's the address of the API server. So if you're used to something called cloud init, hopefully you all are, you're OpenStackers. You're injecting the API server in. The kubelet says, oh, I'm going to go to the API server and go get my configuration. So it's going to pull down. So that node basically has nothing in it except the minimum it needs to join a cluster, which is the Kubernetes component called kubelet. API server gets that new node request, and it's pretty smart. It doesn't say, oh, you're friendly. I'm going to hand you all this configuration and keys and cryptography information and let you into my trusted network. What instead it says is, hey, who knows about this node? And so there's a pattern called node admission in Kubernetes that lets you build a list of trusted nodes or build a webhook so that the API server can call out to another system to say, do you trust this node? They said they were Joe. Were you expecting Joe? And if that node admission protocol says yes, then the API server sends the configuration back down into that cluster, and kubelet comes online as a regular server. It's actually pretty simple if you think about it. And if you're used to Chef or Puppet or any of these agent-based systems, they all have this type of whitelist authorization system where you can say, new nodes are allowed into my cluster management system or not. So it's really a very similar pattern. The advantage here is that then translates into, I never went to full screen. That then translates into a much faster install process because instead of the configuration being driven externally by something like an Ansible playbook, right? So if I was going to do this same pattern with what I just showed you, when a new node came online, I would have to, one, give it SSH keys, which not everybody wants to have to do. And then I would have to then let Ansible run against that new node. So I'd have to track that there was a new node, where it was, generate my inventory file, and then wait for Ansible to complete. And then that's going to take more time. I'm not just dragging down the containers I need and booting it up. It's not a big amount of time, and that might not be a problem for you. Kubernetes community isn't necessarily the Ansible community, and so they don't always value configuration tooling, which is why you see things like kops and kubadmin, pieces like that. But you do get a much faster install, and it's going to be optimized. The other big benefit to it that people like is you get this centralized configuration of the cluster. So the idea here is that instead of having the configuration of your Kubernetes cluster controlled by an external thing, like an Ansible inventory file, or configuration file, what it's being controlled by instead is Kubernetes itself. And so there's a lot of patterns in the Kubernetes world where you actually do self-hosting, and the Kubernetes community loves to have Kubernetes tell Kubernetes what to do and run Kubernetes and things like that. You've never seen, I know this is really unusual to see a community that loves its own self and tools so much that it uses those to the exclusion of other tools, but it's happening in this case. It's a very unusual circumstance. My sarcasm's not working at all for this audience. So that's a big part of it. The other thing that's nice here is that you can then do coordinated upgrades. So sort of the idea here is if you're really all in on Kubernetes, this allows the system to configure itself back through the process. Okay. And then it looks sort of like this, just to give you a visual. What you end up with is I have my old version going, I have my new version going, so I actually have an A/B test, and then I bring in new nodes, and those new nodes aren't even defined. They're going to get whatever configuration is going to come down through the admin server. So it's a very flexible, fast process for trying to roll out these changes. And then from a physical infrastructure pattern or a cloud pattern, it means I'm just constantly rolling my updates and upgrades. So you might be in a situation where your data center has no node that's been running for more than a week, or potentially even faster than that. So if you're worried about nodes being compromised or you want to make sure you're always refreshed, then you could cycle your system through and every node gets rebooted or reinstalled every week. I don't know how many of you think that's crazy. It's actually a pretty effective pattern. From a security posture, it's an even more effective pattern, especially if I've been able to turn off SSH on that infrastructure, which is part of the goal here.
Yep. We're running out of time, unfortunately. So if you have any questions, we are open to discuss with you after the session. If you have any extra questions, there is a website of the project on GitHub. Can you, yeah.
Halfway through.
Perfect.
Cool.
And the Slack channel called Kubespray in Kubernetes Slack. So we're open for your questions, and thank you.